Okay, section 5.2 is polynomials. A polynomial is a monomial or a sum of monomials. We're going to add, subtract, and multiply polynomials in this lesson. Okay, so the first example that we have here is subtraction. What we want to do is take a look at our like terms. We have a squared term, a linear term, and a constant in both of our polynomials. I've highlighted the squared in yellow, the linear in green, and the constant in blue. We will subtract those terms that are alike, and we end up with 2x squared minus 4x plus 5. Next example. Similar problem. We do have two squared terms in this example. One, though, is p squared, and another is q squared. So those are like terms unto themselves. Also a subtraction problem. I've highlighted the p squareds with yellow, PQ combinations with green, and the q squareds in purple. When you subtract all the like terms, you end up with 3p squared plus 14pq minus 10q squared. Addition works the same way, but both of my examples were subtraction. Make sure you're distributing the negative. All right, next we have multiplication. First, what we'll do is we'll take a look at multiplying two binomials. You may remember the expression FOIL. FOIL stood for first, outer, inner, and last in the multiplication process. Here is a binomial, 5 minus 4x times the binomial 3 minus 2x. So we're going to multiply first times first. Outer, inner, and then last times last. You can see I've highlighted that here. If we do first times first, we'll have 5 times 3, that's 15. Our outer product is negative 10x. Our inner product is negative 12x. And our last is going to be positive 8x squared. At this point, we have like terms. We have two linear terms, negative 10x and negative 12x. We want to combine those. So 15 minus 22x plus 8x squared. All right, here's a second example of FOIL in action. Remember, first times first, 2x, 3x, outer, 2x, 5, inner, 1 times negative 1 times 3x, and last, negative 1 and 5. When you do that, you get 6x squared plus 10x minus 3x minus 5. Again, we have like terms. 10x minus 3x is 7x, and there's your final answer. An example like this will also end up using FOIL. Be careful not to distribute that 2 across addition. You can only distribute when you have multiplication. My first step in this problem would be to rewrite 2r plus 7 times 2r plus 7 and then proceed with the FOIL. Again, you're going to have like terms, you add those, and there's your final answer. There is a pattern to this particular example, which we will talk about later in the chapter. Okay, here we have an example of monomial times a trinomial. For this particular problem, you want to distribute your monomial to every term in your polynomial. So negative 5y squared gets multiplied by everything. When you do that, you end up with negative 5y to the fourth minus 10y cubed plus 15y squared. There are no like terms, so we are done. That's the answer. And the last example here, we have a binomial times a trinomial. Binomial times a trinomial, and we don't have a fancy word like FOIL, but basically it's just the distributive property. We're going to take the x, and we're going to make sure we multiply x by everything. And then we're going to do the same exact thing with the negative 1. We're going to take this negative 1 and we're going to multiply it by this, and by that. It's probably easy to see it if you separate it. X times the whole trinomial, negative 1 times the whole trinomial. You don't need to separate it if that's not something that you would need to do, but this will help you keep it organized. Then you end up with x cubed minus 3x squared plus 4x minus x squared plus 3x minus 4. Of course, at this point, we're going to be looking for our like terms. We have 1 cubed, we have 2 squares, here's our squares. We have 2 linear terms, and we have 1 constant. Once we combine everything, you end up with x cubed minus 4x squared plus 7x minus 4. And that is our answer. Thank you for watching this lesson. We will practice in class tomorrow.